Okay, welcome to our next video. This is going to be on the periodic table of elements. Well, first, let's have another look at the periodic table of the elements from ptable.com. And what we're going to be talking about in this video is the fact that there are different rows that go across the periodic table, and these are numbered. Here's the first row, second row, third row, fourth, fifth, sixth, and seventh. The periodic table is also set up in columns, 1, 2, 3, and so forth. There's a certain reason why the periodic table is set up in columns, numbered 1 to 18 across, and why they're set up in rows 1 through 7. We're going to talk about how we go about putting them and why we go about putting them in the correct row and column. So let's start off with the first element on the periodic table. That's period 1, and periods are called the rows that go across, and groups are the columns that go up and down. So let's talk about period 1, group 1, hydrogen. Remember from our video when we talked about atomic structure, hydrogen has 1 proton in the nucleus, no neutrons at all, and 1 electron that orbits the nucleus. Okay, if we look back at our periodic table and look at hydrogen in the upper left-hand corner, the one that's flashing, you'll see here that the 1 here represents hydrogen having 1 electron orbital. And in that orbital, there's 1 electron. So if we go to helium, and we know that helium has 2 protons, 2 neutrons, and 2 electrons. So right now we're looking at 1 orbital with 2 electrons in it. So if we go to the periodic table, we see that helium, which is over here in the upper right, the one that's flashing, helium has 1 orbital. It's in the first period, but it's over here in group 18, and we're going to talk about why these have these numbers. But for the first electron shell, and only the first electron shell, the maximum number that it can hold is 2 electrons. So helium is sitting over here in this last column, this last group with these other elements, because its electron shell is filled with only 2. Okay, so now we're going to go to the second period and the first element, lithium. And remember, this 3 tells you that's the atomic number, so it tells you how many protons it has. Okay, so let's look at lithium. Okay, from here on out, we're just going to represent the nucleus as a red dot. I'm not going to go through the time to put in 3 protons and the correct number of neutrons. That's from our last video, and you should be able to figure that out. So I'm just going to represent it with a red center, because in this video it's really the electrons that we're concentrating on and that are important. So lithium has 3 electrons, 2 in the first shell. Now we've added another shell, and in that shell it has 1 electron. And if we look back at the periodic table, we can see now this is in period 2, representing 2 electron shells. And it's in group 1, which means that in that second shell there's only 1 electron. And this is a trend that's going to be repeated over and over in the periodic table. So let's look at their lithium is flashing, so you can see second group. Now let's look at the next one, which is beryllium. Okay, beryllium had an atomic number of 4, and it's in the second period, so it has 2 electron shells. The first shell holds 2, and the second shell for beryllium now holds 2. Okay, so we can see that beryllium is in the second period, and it's in the second group. It has 2 electron shells and 2 electrons in that shell. So the next element we're going to talk about is boron. Okay, and if we look over here at boron, it's got atomic number 5. So it's got 5 protons, which means it has 5 electrons. Okay, now it's in this group that's numbered 13. These elements right here that are in this block that's right here, these are what we call the transition metals, and we're not going to talk about those right now. What we want to concentrate is just the first 20 down to calcium. We're going to introduce these at another time. So what we really want to concentrate is on this last number right here, the 3. So if I'm guessing correctly, I'm going to say that boron has 2 electron shells, and in its second shell there will be 3 electrons. And if this trend is correct, we can see here that boron does indeed have 2 shells, and in that last shell there is 3 electrons. Okay, now carbon. Carbon, second period, 4 electrons in its outer shell. Okay, 2 electron shells, 4 electrons in its outer shell. Okay, we call this outer shell the valence shell, and we call the electrons that sit in that shell the valence electrons. So from here on out, that's how we're going to refer to these, as the valence shell and the valence electrons. Okay, so after carbon comes nitrogen. Nitrogen, the number here is 5, so it should have 2 shells and 5 electrons, and indeed it does. Okay, oxygen should have 2 shells and 6 electrons, 2 shells and 6 electrons. Fluorine, 2 shells, 7 electrons. 2 shells, 1, 2, 3, 4, 5, 6, and 7 electrons. Okay, I'm going to go ahead and add in this electron. This is now neon, and neon sits in the last column, column number 18. That column is very special. This last valence shell can only hold 8 electrons. That's the maximum it can hold. And in fact, in chemistry, 8 is a very important number. As a matter of fact, 8 is a magic number in chemistry. When an atom has 8 electrons in its outer shell, that shell is full. That's what all atoms on the periodic table are seeking to be like. When it has 8, we say that it's happy. That last shell is filled. Okay, these are called the noble gases, and the reason that they're called the noble gases is because nobility, when you think about kings and queens, they really don't mix with the commoners. So it's really to say that all of these elements that are in this last group here do not bond with any of the other elements on the periodic table. Okay, so this last atom that we're looking at, this has now 3 shells. So once this shell has 8, now remember the inner one can only hold 2, and when that got filled, we added another shell. We kept adding electrons until it got 8. Then we add another shell, and we're going to continue to fill this shell until it has how many? Correct, 8. So this first one we're looking at is sodium. It's got 3 shells, electron shells, and 1 electron in that shell. So the next one is going to be magnesium. Added another shell. Aluminum, silicone, and I'm going by memory here, I think it's phosphorus, sulfur, chlorine, and finally the last electron that's added is happy, and that would be, I believe, argon. Yes, it is argon on the periodic table. Okay, once we have that shell filled, then we go back over, we start a new period. Okay, this potassium is going to have 4 electron shells, and it's going to have 1 electron in that shell. And finally, calcium, which is where we're going to stop for this video. Calcium has 4 electron shells, and it's got 2 electrons in that shell. Okay, so now we're looking at a mystery element. We don't know what this is. I haven't told you. So what element does this represent? Well, it's going to be in period 2 because it has 2 electron shells. And it's got 1, 2, 3, 4, 5, 6 electrons in its valence shell. So if you want to pause the video and grab a periodic table or open another tab in your browser and go to ptable.com, look for the element that's got 2 shells and 6 electrons in its outer shell. Okay, did you find it? 2 shells, 6 electrons in its outer shell. We're looking here at this 6. We're going to say this is oxygen. Oxygen is in period 2, and it's got 6 valence electrons. So this represents, it's a Bohr model that represents oxygen. Okay? Well, we're going to use this information about valence electrons to draw what we call a Lewis dot structure. Now remember, hydrogen has 1 valence electron. So the way we draw the Lewis dot structure for hydrogen is with 1 dot. Sodium is right under hydrogen, and it also has 1 valence electron. So sodium's Lewis dot structure has a 1 single dot. And it doesn't matter where you place these dots around the symbol, as long as you place the correct number. Okay, and lithium is under sodium, and you see here lithium has 1 valence electron, and I've decided to put the dot under lithium. It really, like I said, does not matter where you put the dot as long as it's just 1 dot. Beryllium has 2 valence electrons, so we have 2 dots. Boron has 3 valence electrons, so we draw 3 dots. Carbon has 4 valence electrons. You guessed it, 4 dots. Nitrogen, 5. Oxygen, 6. Fluorine, 7. And neon, which is a noble gas, has 8 dots. So a question I'm going to ask here is, what's the maximum number of dots that you can have around an element? If you said 8, you would be correct, because remember, the last shell can only hold 8 electrons before it adds another shell. So it's that magic number 8.